What's up, everybody? I'm Jason, and welcome back to episode 2 of my series that's essentially a brain dump of everything I know and understand about light and lighting. And the intent of this series is to provide you with the kind of foundational information that I've struggled to understand or gather as a small budget, low budget, or YouTube videographer. Now, in the first episode, I talked about tungsten lights, and this episode is going to finish up the four main lighting, or the final three of the four main lighting technologies that you may come across in video centric circles. Those are, in this case, HMI, fluorescent, and LED. So let's just jump right in. And we're going to start with HMI, which is a mercury medium arc light. The H is the old Latin word for mercury. I'm not even going to try to pronounce it. And basically, this is a mercury vapor arc light. I'm not going to get too into the weeds on HMI because, quite honestly, it's not a technology that a small budget shooter is probably going to really mess with or care about. So, what you need to know about HMI, as well as basically all of the lighting technologies in this video, is that none of these technologies are black body radiators. So, none of these work like a tungsten light. None of these work like the sun or fire or a candle flame or whatever. They all use some other method to produce light. So, in the case of, and as a consequence of that, the color that the lights put out, the emission spectrum that the lights put out, doesn't directly or naturally match that of a black body radiator. So they can look very similar, but there can also be color shifts potentially in the subject matter that you're shooting, even though you're using a light that's daylight balanced. So in the case of an HMI light, they are approximately 6,000 Kelvin is a correlated color temperature. So they're, broadly speaking, daylight lamps or daylight balanced, which makes them useful, obviously, when your options are tungsten and HMI. And to get tungsten to daylight, you have to put a blue gel on it that eats like 30 or 60% of the light. Having a light that's inherently daylight balanced is going to be beneficial. Now, HMI, as far as I'm concerned, has a whole slew of problems that were fine for people like in Hollywood and big budget type stuff. And there are places where HMI lights are still applicable in terms of they're really bright and they're daylight balanced. And so if you need fill light on, in an outdoor environment during daylight or during the daytime, an HMI light can be the right tool for that application. But they have, as far as I'm concerned, a number of problems that make them very unattractive as a video light for lower budget type things. So, first of all, the HMI lights can flicker. The video centric ones, which is really where you're going to come across HMI anyway, tend to be better than something like a warehouse metal halide type light or something like that. But depending on the manufacturer, depending on the ballast, there can be flicker issues if your frame rates and shutter speeds aren't set properly or timed properly. Now, if you're looking at video lights from ARRI, or really that's the only company I can think of off the top of my head that does HMI for video applications or cinematography applications, if you are looking at their lights, their ballasts have flicker-free modes. Their ballasts, they even have high-frequency ballasts that run up to like 1,200 hertz to provide a flicker-free image at, even when you're shooting at high frame rates. So there's workarounds for that available, but it is something that you can run into. Second of all, they have a very limited dynamic range. There's a very limited range of control for HMI lights, and again, using ARRI because they're the gold standard for this, the best that you can get is 50% to 100% dimming, or dimming from 100% to 50%, which that's not a huge amount of control over a light, especially like when you can dim tungsten down, way lower than that, and especially dim LED down way lower than that. And finally, the last sort of major problem is that they are generally very high output. So a small HMI lamp is going to be in the 575 watt range, which is like a lot of light. And especially with not being able to just dim that to 5 or 10%, it's not going to be something that you're going to want to mess with in a small environment. And they get much bigger than that. They get up to, I think, at least 10 kilowatts, if not more. Additionally, because of that high power and due to the way a mercury arc lamp works, there's thermal and light level and UV, because mercury arc lamps or mercury lamps do emit UV light. There's minimum safe distances for, say, flammable things. There's minimum safe distances for how close you should have or you should be to the light source, or looking, especially if you're looking towards the light source or at the light source. And generally speaking, this is quite significant for the small, like 575 watt RE Fresnels. It's like 7 meters or 28 feet or something to that effect. So HMI, in brief, is not a technology that's really worth considering if you're looking to buy a light. However, I think it's worth at least having in the back of your mind, because there are applications where HMI is the right tool for the job. But this is more of a thing that you would rent these if you needed them, as opposed to buying to have in your kit in general. Now, of course, like I said, they pose a number of concerns from the limited control, so it's harder to make them do what you want. That the ability that basically that the ability that you can't really dim them a lot. They're high powered lights that there aren't very small. Like, you can't, as far as I know, you can't get like a 50-watt HMI or something like that that produce lots of heat. They do produce UV. The front lenses, or the lenses in an HMI light, should be filtering the UV or most of the UV, but there's still, we're talking about very high powered lights. And, as I said, they're something that I don't recommend really considering, but they are worth knowing about in case there is instances where they can be the right technology for the or right app tool for the application. So the second technology on the list of technologies in the show today is fluorescent lights. And, fluorescent lights were the primary sort of alternative to tungsten prior to LEDs. So they were the big, if you needed a lot of light, you needed things to be cool, didn't have huge budgets to spend on air conditioning and studio quality air conditioning and so forth. Fluorescents were sort of your go-to technology. So to get off a little bit in the technical weeds, fluorescent lights are a gas discharge light, which means that an electric current is run through a tube full of a gas. In the case of what we're talking about, it's a mercury vapor. And that current excites the mercury atoms in the tube, which cause the electron states to shift, which causes the atoms to emit photons. And, as I said, consistent with all of the technologies that we're talking about today, this is not a black body radiator, so it doesn't produce that natural emission spectrum that you might be, focusing on or needing or wanting in some applications. So again, back to fluorescence. In the case of fluorescent lights, the excited mercury atoms, and this is again similar to HMI, produce UV photons. Those UV photons are absorbed by the milky white, so recognizable as a fluorescent lamp, this white or white tube. That white is caused by the phosphor that coats the entire tube or the entirety of the lamp tube. That phosphor absorbs the photons emitted by or at least the UV photons emitted by the mercury vapor, and re-emits that as visible light. Now, as I said, because this is not a black body technology, the color emission spectrum is not continuous. There's spikes, there's dips, there's weird kind of things going on. On a plus side for fluorescent lights as a technology as a whole, the color temperature or the correlated color temperature that the light produces can be tuned by the designers and engineers of the light by adjusting the phosphor. So, where tungsten lights are always going to be like 3200 Kelvin, and a HMI light is always going to be 6000 Kelvin, unless, obviously if you gel them, they could be something else. But the technologies inherently are that. Fluorescent lights can kind of be, whatever the designers want. So you can certainly get fluorescent lights that are, quote, warm white, that are like 24, 25, 2600 Kelvin, all the way to daylight lights at like 5500 or 6500 Kelvin. And now, granted, you can't change things in the lamp, in the field, or as a end user, but you can change the lamp. So if you have a fixture that's designed to use fluorescent tubes, so for example, like a KinoFlow fluorescent lamp, fluorescent video fixture, you can switch between tungsten tubes and daylight tubes to change the color temperature of the light that you're actually using to shoot with. Now, one thing to know about the color of fluorescent lights is that if you're not shooting with lights that are specifically intended for photographic or video applications, you will probably run into lights that have a green cast. And the only thing you can do about this is account for it and deal with it in your shooting setup. So if you only have one or two fluorescents in your scene that you're working with, maybe you replace them with photographic ones. If you're shooting something in an office environment like that's lit with fluorescent fixtures overhead, then what you'd probably want to consider doing is putting green gels on your whatever lights that you're using, and then pulling you're fixing the green cast that everything is going to have with color balance in your camera or in the color grade in post. But you need to be aware of the color shift that will exist between fluorescence and, the green shift that will exist between fluorescence and basically even fluorescent lights targeted for videography or cinematography. Now, fluorescent lights do have some disadvantages and some concerns. For the primary disadvantage, really, with fluorescent lights, as far as I'm concerned, is the lack of control. There are dimmable fluorescent lights, but as far as I know, nobody has ever done dimmable fluorescent lights in a photographic context. It's been a household or commercial thing that it's complicated, it's expensive, it's kind of cobbled together as all in one thing. It's not they're not usually really good quality lights. Additionally, they're not dimmable per se in the sense that where you might be used to with video lights where it's you can continuously dim them. There's more of a stepped nature to the dimming. Instead, what the video light manufacturers do, so for example, KinoFlow or Westcott with their spider lights, is they allow you to independently switch multiple lamps. So for example, a typical KinoFlow fixture uses 4 tubes, each of which are independently switched. So you can have full power with all 4 tubes on, or you can turn off tubes as you need to adjust the power output to what is necessary. So turn off 2 tubes, you get 50% power. Turn off 3 tubes, you get 25% power. The additional concern, problem, potential issue with fluorescent lights is, again, that mercury content. So in general, in my experience, it seems to be that fluorescent lamps are being phased out pretty much across the board. Commercial, residential applications, nobody really is doing or wants fluorescence anymore. Everybody's going to LED. And the same thing is in video and photographic applications. For example, KinoFlow's fixtures, fluorescent fixtures, they've announced they're going to be discontinued soon. I'm not Westcott Spider Light, I haven't looked at, but is maybe a little bit different because you could mount LEDs on that and use that with LEDs instead of fluorescent tubes. But broadly speaking, the move in the industry and both cinematography and the regular kind of commercial world, is to move away from fluorescent lights. And this is in part because there are some risks potential with them. So there is mercury vapor in the lamp and the tube and the envelope, and that is potentially, if your lamp breaks, that's potential for mercury exposure, mercury contamination. It's technically a hazardous material that poses some concerns and risks for both health and environmental risks in disposal due to that mercury contamination. And then, just from a straight up practical sense, in a photo or video application, that they are not as good of lights for control and even for power efficiency as LEDs are at this point. And LEDs have basically overtaken them or matched them in terms of color quality. So when you have a technology that's more efficient, equally good color wise, and easier to control over a much wider range, well, it's kind of a no brainer why the technology is going that way. So, where was the big boon in fluorescent lights? Well, the big boon was in efficiency. They're substantially more efficient than tungsten because they are not producing all of that heat. And in fact, this lamp that I showed you here, this is a photographic, it's made by Westcott, or was made by Westcott. This is a 50-watt fluorescent lamp. Now, not a 50-watt equivalent like you might commonly see if you went to, the hardware store or whatever. This is a actual uses 50-watt lamp. And this is equivalent to, well, in straight light output, it would be equivalent to about a 200 or 250 watt tungsten lamp. However, that's a daylight balanced lamp, not a tungsten balanced lamp. And if you actually threw gel on the tungsten to match the color temperature, you're talking about a 500 or 600 watt equivalent tungsten, gelled tungsten to daylight situation. So they're significantly more, fluorescent lamps are significantly more efficient compared to tungsten from a power perspective. And of course, because they don't produce all of that infrared light, working in front of one means that you're not sitting basically in a, radiant oven, essentially. So summing up fluorescent lights, in brief, they're basically obsolete technology at this point, or at least obsolescent technology. They're not something that I would not recommend buying into fluorescent lighting for a video lighting setup. I think you're better off buying into LEDs straight up across the board now. That said, in some way, the same respect as HMI is worth having in the back of your mind because it might be the right tool for the job at some point. Fluorescent lights are worth having a little bit of an understanding of because you may run into them in the environments that you're working in. So if you're doing a job that involves shooting in an office space, a lot of older offices that haven't been, or that aren't new construction or haven't been completely retrofit will use fluorescent lights in their overhead lighting fixtures. And so you need to be aware of the color cast issues that you may run into with them. And that brings me to the last technology that I want to talk about in this video, which is LEDs. And LEDs are easily by far the fastest growing lighting technology for video production today. And some of that is, like most things electronics related, they shift so much of the burden of production, design, and engineering out of super specialist fields. And it becomes something that any company that can do electronics manufacturing or electronics design can start to actually produce products, or can actually produce products that are, quality, functional, capable devices using LEDs. Plus, from an end user perspective, they just beat all the other techs hands down when it comes to controllability, adaptability, and straight up efficiency. So, talk about the tech a little bit. LEDs are light emitting diodes. They're solid state technology, which they're made out of semiconductor materials. They're basically the same sort of thing that goes into making your computer compute and your smartphone smart is what's being used to manufacture an LED diode. A little bit different, a little bit more involved, different processes, but broadly speaking, that's the same. It's the same kind of fundamental stuff, and they work basically by when a current is passed through this diode, the combination of semiconductor materials and the design of the semiconductor materials, they spit out photons, and they spit out photons in a very small emission spectrum. It's a very narrow emission spectrum. They produce very pure colors. So if you've ever played around with like RGB LEDs for light strips or even an RGB LED light panel, you'll notice probably how blue the blue looks and how red the red looks and how green the green looks, that they're all very almost fake in some respects looking colors because they're so pure. There's not a lot of contamination in or distribution in the color or that the lights put out. Now, as a sort of interesting sort of technical aside, there is no such thing as a white LED fundamentally. There are obviously white LED lights, there are white LED diodes, but the way this all works is kind of a throwback in some respects to fluorescence. So you basically have two ways to get white light out of an LED system. One is you have red, green, and blue diodes in your package, and you simply run them all, and that produces what looks like white light because of the mixing. So that's one approach. The other approach is, and this is the more common approach with typically what's marketed as a white LED. And yes, it does produce white light, and yes, it is an LED, so it's technically, yeah. But which is you have fundamentally a blue or potentially UV LED that has a phosphor built into it or built over it into the diode itself, into the little tiny package that fills in all the rest of the color spectrum. So it takes some of the blue light that is being produced by the LED or all of the UV light that's being produced by the LED, and it re-emits that as a fuller color spectrum so that it's white, looks white. Now, the thing to understand about LEDs and color is that the quality of the LED does matter a lot. And this is something that it's getting better, but you have to kind of always be aware of it. And there's a lot of subtle tricks that I'll talk a little bit in the next video about, probably about how color rendition, CRI, color rendition index, is gamed or can be gamed a little bit to provide not as great of light as you think you're getting, especially in the hard part for LEDs is reds, and there's certainly aspects or situations where you might not, in a video aspect, and red's kind of important because it's like skin tones, etc., might not get as good of a quality light as you think you're getting potentially. So you want to always be cognizant of, if you're buying LEDs, you want to be buying the best quality panels that you can afford, really. Like, you don't have to just go for the best quality lights, but the best quality lights that you can afford. Now, as I said, the situation is getting better. 10, 15 years ago, like, I remember trying to find good quality LEDs, and a CRI of 80 was about the best you could do. Nobody really had much desire to do good or better quality. The focus was basically on producing light and doing it cheaply. Cheap to manufacture as well as cheap for the end user in terms of electric costs. And, that's fine in some cases to some extent in sort of like a commercial household application where you really don't care about color. But for photographic and video applications, color tends to be a little bit more important. So there's been two things that have been working towards this. First of all is the LED fixture makers that are manufacturers that are making lights for video applications. they're competing more. There's more competition, and color quality, color rendition is something that they're competing on, and so that's driving some improvements in that area, um, across the board. The other side of the coin is that in the commercial and household space, certain places are starting to pass regulations that require LED lights to have a certain amount or a minimum level of color quality. So, off the top of my head, I know California has passed regulations on this. The Europe may be on that ball too. I'm not entirely sure, but I want to say I saw something about it somewhere. And I think there may be a couple of other states in the US that are doing the same kind of thing. And, basically, this is one of those situations where, you know, this is a good thing for us as photographers and videographers, because the more places that we shoot that have good quality light in them, the less we have to worry about completely replacing all of the lighting that's available, so to speak. So we don't have to turn off all the lights and then completely relight the room to get a good quality of light in our product. So LEDs do have some, as I said, obviously color is one of those things. As a aside, I should also mention with respect to color temperature and color quality. So you obviously can get LEDs across the spectrum in color temperature. In fact, you can get usually LEDs can be found from as low as 2000 Kelvin, which is basically the color of a fire almost, all the way straight up to 10,000 Kelvin. So really blue to really red. So there's a lot of options out there, a lot of availability for depending on what you want to do. One interesting thing with respect to color rendition in LEDs is that the warmer the light tends to be, the higher the CRI tends to be, and this has a lot to do with getting more red into the light level, because that tends to be the weak spot of LED lights. So another huge benefit through LEDs is control. Way, way, way better control over the light in terms of brightness and dimming. You have the ability to you can readily dim LEDs down by at least 10 stops, which, that's insane compared to tungsten or HMI or fluorescent or whatever, where tungsten and fluorescent you can only dim down to about 5%, which is about a little over 4 stops. HMI is about 1 stop, 50%. Tungsten, you can dim it a lot, but as you get the dimming really low, the color temperature starts to shift because the filament just can't stay, it doesn't have the energy to stay hot as hot. LEDs, you can dim them significantly without significant shifts in the color that the light produces. I say without significant shifts. This is one of those things, it has to be implemented correctly. There are ways to dim LEDs that don't mess up, and there are manufacturers of LED panels that have messed up the design of their panels that will cause them to color shift and be a problem. So, huge amount of control. Plus, as a solid state device, it's essentially you can control it with a computer quite readily, so you can start doing all kinds of effects. And then when you throw into like RGB, you can start doing all kinds of color work and so forth without having to use gels and so on and so forth. The other huge benefit of LEDs is just straight up efficiency, power efficiency. They're even more efficient than fluorescent lamps. And in fact, when I switched from shooting with this 50-watt fluorescent lamp to shooting with LEDs, and I was using just household LEDs in a weird kind of configuration. In fact, they were these. And I'll talk about how I lit things in a future video. But several of these giving me approximately 50-ish watts of output, I actually had to drop my exposure settings by about a stop. I was getting that much more light from the LEDs compared to the fluorescents. So there's definitely, an obvious advantage there. Plus, if you look at any of the photographic lighting stuff, almost anything under 50 watts, well, almost all, or I shouldn't say all, many fluorescent, or not fluorescent, LED light systems can be battery powered. Even what I would consider fairly high powered. So 150 watt or 300 watt lights like Aperture's LS120 or LS300 can be powered from batteries, which, so with tungsten or HMI or fluorescent, where you had to worry about, where you were going to get power on site, or if you were out in the field somewhere, did you have to bring a generator with you? And if you had a generator, where did you have to put it? Because it could interfere with sound or whatever. With LEDs, it's stick a battery on it and go, which is a huge benefit for a flexibility and operation. So there are a couple concerns with LEDs. The biggest one, in my opinion, well, the biggest two are color quality, which is going to be entirely dependent on the fixture, the light LEDs that you're using, which, as far as things tend to be, means that you're not going to have a lot of control of it if you're using commercial stuff, or you're working in a commercial space lit with LEDs. The flip side is video lights. You kind of have to pay attention to what you're buying, because the products do range from really good to really bad. The other real concern is flicker. So there's two ways to, LEDs themselves, I should say, are DC devices. So they don't inherently flicker, but anything that is plugged into an AC outlet or runs off AC power is going to potentially have, depending on how it's designed and engineered, a flicker component to it. So this applies really more to the commercial slash household LEDs, the kind of things that you'd run into as practical lights in an environment that you're working in, as opposed to purpose-built video lights. They're not going to flicker, but being aware of potential flicker situations that can come up with LED lights in the field. Generally speaking, this is going to be more of a problem for you if you're dimming the lights significantly. That's where I see more flicker come from LEDs than if they're run at full power, due to the way dimming circuits tend to work, or dimming tends to work for AC lights. And to a certain extent, this can be combated by using the right frame rates and shutter speeds, which is generally the case for anything that flickers. So to sum up LEDs, broadly speaking, they are the technology that I recommend if you're looking to buy lights for your studio, for using in the field, whatever, they're the technology I recommend at this point. It's a mature market. There's a ton of options out there, and they provide a ton of control. They are, in most cases, can be battery powered, which means no cords, which is great. And broadly speaking, because of the money going into the research for LED lights as a technology as a whole, things just keep getting better. Where even a few years ago, it was hard to find video lights that had better than 90 CRI. It's now really easy to find 95 and 97 CRI lights, which, I don't know if they'll ever make it to 100, but the better the lights are across the board, the better it is for us as people shooting video. So that wraps up this video. If you found this useful or informative, please consider smashing that like button. Please also consider subscribing. And as always, thanks for watching, and I'll see you next time.